The biocomputer is essentially a lab in a box. It contains all the hardware to run common lab workflows and the software to operate it. It can be easily reprogrammed to run different applications, from growing cells for cell therapies through to manufacturing food. We designed the hardware using inspiration from the semiconductor industry, mapping out each unit operation of a lab workflow and understanding the parameters and attributes before encoding them into devices that carry out each step of the workflow. From here, we manufacture collections of these devices into functional blocks using 3D printing, and these combine into one integrated programmable system. Each of the blocks carry out groups of related activities and are brought together as a single hardware architecture to run these complete biological workflows. The workflows can be reprogrammed by software to utilise different hardware devices in different ways. This can allow us to run different applications from the same piece of hardware. The four core blocks are the input-output block, the advanced routing core, the bioprocessing unit, and finally the sensor core. The input-output block, or IOB, is the hardware that controls the loading of raw materials such as media, buffers, gases into the system, and then the removal of the final product, samples and waste out of the system. The advanced routing core, or ARC, is a network of addressable interconnected channels for the transportation of liquid and gas throughout the entire system. It allows us to send packets of liquid or gas, such as a cell culture or reaction mix, to any other part of the system. The bioprocessing unit, or BPU, is where the bioprocesses happen. Different configurations of BPU can be used to carry out applications such as cellular biology or molecular applications. For example, we've already demonstrated cell growth and in vitro transcription applications in our systems. In addition to software programmability, using our digital toolchain and 3D printing manufacturing methods, we can rapidly reconfigure the hardware. This allows us to match our customers' applications and needs. For example, this is a BPU for cell growth. It has all the capabilities of bioreactors such as temperature control, agitation and oxygen injection. The same hardware can easily be reconfigured from a single 10 milliliter cell growth through to multiple smaller scale DOV type assays. We can even add additional capabilities such as ATF perfusion. The final block is the sensor core, SC. This brings sensors and analytics in line and at line within the biological workflows and enables real-time monitoring of the bioprocess, all the way through to adaptive control and machine learning. The sensors can be configured based on our customers' requirements. For example, in cell growth applications, we commonly monitor analytes such as pH, temperature, dissolved oxygen, and cell growth and viability. Leveraging the rich dataset from the biocomputer can accelerate process optimization and allows us to engage performance-enhancing capabilities such as artificial intelligence. These four core blocks come together into an integrated, reconfigurable biocomputer for multiple applications. In the words of a recent Forbes article, the biocomputer is the most simple yet versatile biomanufacturing system in the world. I'm Colin Barker from BiologIC Technologies. If you want to learn more about the biocomputer, check out our website or follow our LinkedIn feed.